Okay, let's see the solution to test number 13. In this test, the question is that a parallel plate capacitor has a plate area of 7.6 square centimeter with a gap of 1.9 millimeter. When connected to a 20 volt DC source, what is the amount of charge stored in this capacitor? Okay. We can calculate this using the definition of the capacitance of a capacitor. That is, if we have a capacitor with a capacitance of C, we have the capacitor with the capacitance C here. By definition, C is equal to Q over delta V, where Q is the charge on the capacitor and delta V is the potential difference between the plate of the capacitor. So we can rearrange these to be Q is equal to C times delta V. Okay. And for the parallel plate capacitor, if you can remember, the capacitance of the parallel plate capacitor is epsilon 0 A over D, where A is the area of the plate and D is the distance of the gap between the plate. Okay. But if you cannot remember this formula, it is very easy to derive. So let's see, we will briefly derive the capacitance of the parallel plate capacitor. If you can remember that if we have a plane that has a charge uniformly distributed, it will produce the electric field. And from symmetry, we know that the electric field will point in the perpendicular direction to this plane, right? So if we create a Gaussian surface as a dashed line here, which has an area A here, and the two ends of the Gaussian surface here are at the same distance from the plate, we may have this L, and this is also L. Okay, so we know that the electric field on this surface and on this surface are equal, and when we calculate the flux of the electric field that passing through the Gaussian surface, we can see that the flux on this side will be 0 because the electric field is perpendicular to the area vector. Okay, we have the area vector like this. So E dot dA on this side and this side will be 0. So we already have the flux that passing to these two ends only.